Today is the first class on Kubernetes. My guess is Kubernetes will take around 4 classes. That's today, tomorrow, and next week. Maybe there might be some offline classes here and there in the middle as well. It's a vast topic, but at the same time, we don't have to dive into the internals of Kubernetes too much. We will from time to time. But the goal is to understand how we can use Kubernetes to deploy applications as an application developer, and also understand all the systems that exist inside Kubernetes. If you've already dived deeper into Kubernetes, if you've already worked as a DevOps engineer, then a lot of this might be straightforward. At least today's class might be super straightforward. Let me give a brief of what we'll be doing today. We'll first be understanding what is Kubernetes, how we used to deploy things before Kubernetes, how do we deploy things after Kubernetes. We'll understand some standard jargon to know. Maybe I'll do a poll to understand how many of you already know a bunch of this, how many of you don't. Then we'll be spending a bunch of time to create a Kubernetes cluster. We'll be creating it locally today, but tomorrow or next week, we'll try to create it on some cloud provider like AWS, GCP. Then we'll understand about the Kubernetes API. A bunch of things from here to here basically is going to be what are pods, what are deployments, what are replica sets, and what are services. Services we might do tomorrow as well. We'll probably just focus on from here till slide number 17. So that's a brief of what we're doing. Now, whatever words I've said, how many of you already know this a little bit, have done this in the past? Let me create a quick poll to understand, do you know this / have heard of this? Some of these things, do you know kubectl? Do you know what are pods? Have you heard of them at the very least? And what's your level currently? Let's see, save the poll and launch it. This will also give you an idea of, where the class is generally, and can decide. All right. So 80% no, 20% have decentish of idea or some idea. Great. That means we'll take it slow. We'll do a lot of polls, and we'll understand in this in a very beginner friendly fashion. All right. Without any further ado, the recording has started. Let's get right into it, guys. Let me also connect my iPad today because slightly visual class. We're going to understand about Kubernetes. This technology was introduced at Google a few years ago. Eventually they open sourced it, and it is primarily used to deploy applications. Harkirat, we to have deployed applications in the past without Kubernetes as well. We deployed it directly on EC2. What exactly does Kubernetes give us? And here I will introduce our very first jargon called container orchestration. There are two words here to learn: containers and orchestration. Containers, hopefully we understand by now. Okay, Harkirat, we used Docker to create these small machines, mini machines, self-dependent containers inside which we used to run our front-end applications, sometimes back-end applications, sometimes even MongoDB. We used to run inside containers. So containers became a more generic concept, primarily made famous by Docker. A lot of companies started to use containerization. KR, if we have a code base on GitHub, let's say this is github.com/Facebook/backend, let's say. Then whenever we deploy this on, let's say, an EC2 machine, we run Docker over here and we deploy this in a small Docker container. We do not directly take this, let's say, Node.js code and put it on an EC2 machine. We don't run it natively over here. We run it on a Docker container. What is the benefit of doing this? Your application is isolated. It's very easy for you to start it on a fresh EC2 machine. If I bring up a fresh EC2 machine and I want to start, let's say, my facebook.com/backend over here, then I will first have to install Node, then have to install maybe PM2, then install a bunch of dependencies. Then I will have to run node index.js. There are a lot of steps I have to do, and I have to repeat them on every machine. If I move over from AWS to, let's say, GCP, then again I have to do the same things. I have to install Node.js there. I have to understand what are the steps to install Node.js on that machine. And hence came the concept of containers. KR, doesn't matter what operating system you're running it on. It could be an EC2 machine. It could be a Google Cloud provider machine. It could be a Mac machine, doesn't matter. You install Docker there. That is the first thing you have to do. And once you have installed Docker, all you have to do is Docker run and then image name. If you run this command, there will be a mini container that will be started. This will be a self-sufficient container. It will have Node.js. It will have all the dependencies that are needed to start your application. A single command can run it everywhere. That is the benefit of containers. That is what a bunch of runtimes give you. Docker is just one container runtime. Now there is Pod-1, if you've heard of it. A bunch of other popular container runtimes exist. Docker is the most popular one, sort of, has built a good business around containers. But then came a new technology, container orchestration. What does orchestration mean? Who is an orchestrator? If you've seen operas at all, there's a person who's orchestrating, violin guy, guitar guy, so on and so forth. That is what an orchestrator is. And hence, what would container orchestration mean? It would mean that if you have a bunch of machines, if I have, let's say, an EC2 machine, and even maybe a GCP machine, and maybe my own machine in a data center that I sort of rented. What if there could be a process that could be like, acha, backend server, go here, start a small container of backend over here, front-end container, go here, start a small container of front-end over here. And if this backend container, let's say, goes down for whatever reason, it would restart the backend container. What if something could orchestrate, you run here, you run here, you run here, rather than the developer first starting a machine, then installing Docker on that machine, then doing a Docker run. If it ever goes down, the developer again going into the machine, again running Docker run. There is so much effort that even though it's containerized, there is some benefit on it being containerized. But until you have container orchestration, unless you have someone who's constantly looking at your cluster, another jargon I'm introducing here, cluster. What is a cluster? A bunch of machines you might have, an EC2 machine, a GCP machine, another EC2 machine, let's say, and then your own machine in a data center. If there is someone who's looking at this cluster constantly, and you could just tell that someone, okay, bro, please run 2 containers of my backend, 1 container of my front end, and then, 2 containers of maybe Kafka. And then that thing orchestrates itself. I have to run 2 backend containers. Let me run 1 over here and 1 over here for resiliency. In case this server goes down, there is a backup container running over here. When this does go down, this orchestrator only starts the backend container on another server. It is constantly keeping track of what services have gone down and restarting them based on this spec that you give him. Another jargon I introduced here, spec or specification. You give it a specification, you give it a file where you say, please run 2 containers of this image, 1 container of this image, 2 containers of this image on my cluster. Here are a bunch of machines that I own. And then something, which in this case is Kubernetes, orchestrates those things running over there. That is what Kubernetes, or more specifically, container orchestration means. Let's read through the first slide. What does it say? Docker is a prerequisite before you start. You can do Kubernetes without Docker as well. There are various container runtimes, as I said. But at least for today, the way to start Kubernetes locally will use Docker, and the containers that we'll be running are also going to be Docker containers. So you should have knowledge of Docker. You should also have Docker installed locally today. Kubernetes, popularly known as K8s. So this is some jargon that we'll use throughout the slides. Whenever I say K8s, it means I'm saying Kubernetes. Why is Kubernetes called K8s? Because after K, there are 8 characters before you reach S. Kubernetes is a container orchestration engine, which, as the name suggests, lets you create, delete, and update containers. This is useful when you have Docker images in the Docker registry, let's say, and you want to deploy them in a cloud native fashion. What does cloud native fashion mean? It means you don't want to worry about EC2 I want to deploy or GCP I want to deploy. I want my application to be deployed anywhere. If you want, Kubernetes is a cloud native technology. It works with AWS, it works with GCP, it works with your own data center as well. As long as you can install the Kubernetes software there, it will just work. You have to do the same things / follow the same steps to deploy your application on GCP or AWS, as long as you have a Kubernetes cluster over there. You want to not worry about patching crashes. If your container ever goes down, you want Kubernetes to take care of it and bring it back up. You want the system to auto heal. You want to auto scale using some simple constructs. Harkirat, we can auto scale without Kubernetes as well. Yes, you can. There are many ways to auto scale, create more servers, create less servers. Kubernetes lets you do it in very simple specification files or specs. You can write down the CPU usage if it goes above a certain level, start more servers, bring down more servers. You can do it outside of Kubernetes as well. This isn't the biggest selling point of Kubernetes. The bigger selling points are, if you want to ever make sure it's very easy for you to move from AWS to GCP, then Kubernetes is a great choice. If you want to not worry about patching, if you want someone else to always keep on looking at your resources and restarting them, then it is a great choice. You want to observe your complete system in a simple dashboard. You want to see, what all machines am I running? What all containers am I running inside them? For example, here I showed, we had 4 machines. And this machine was running a backend container. This machine was running a backend container. What if you could see all of this in a nice dashboard, discover your system? We have 4 nodes up currently. And amongst these 4 nodes, we have X containers running. If your node goes down, you can see that in a dashboard. You don't have to worry about restarting machines and installing a software there. Everything else is done for you. That is a brief of why you would want to use Kubernetes. As we go through the slides, you'll see this in a little more detail. What does a final Kubernetes cluster look like? How would your application look like deployed on the internet if you're using Kubernetes? You will have multiple machines like this, for example, AWS machine 1, 2, and 3, and you'll be running your containers over here. What are containers? Think of them as Docker containers for now. You created an image for your backend. What was an image? If I go to Docker Hub and let's say open an image, this is the Nginx image. You can create your own images. If you remember back to the Docker class, we would containerize our application. We would convert our Node.js application into an image and push it over to Docker Hub. Given you have this image, let's say your own image for your own Node.js process, you can start it like this in various machines. And then your end user can hit an endpoint that looks like backend.100xdevs.com. And the request will eventually reach either this container or this container or this container. There will be load balancing to make sure that the load is distributed correctly across all of your containers. You run a single command. I want 5 replicas of my backend. I want 5 containers of my backend. And something else takes care of adding a new backend here, adding a new backend container here. You want to downscale. You change just a number somewhere. You change a number from 3 to 1. It destroys this container and this container. You have a single container that is remaining. That is what Kubernetes, or more specifically, container orchestration stands for. Kubernetes also known as KTS. Why? Because this. All right. Cool. Too much detail to dive into too early. So let's take a step back and understand how did we deploy applications before Kubernetes. Now we've deployed applications many times. We deployed it on AWS. We deployed it on an EC2 machine. We also deployed it using CDNs, if you remember, specifically front ends. So how have we deployed applications until now? If you remember the auto scaling group class, we created an auto scaling group of multiple machines. There is backend machine 1, backend machine 2. You can increase these number of machines, decrease these number of machines where your Node.js application is running. And you would have a load balancer in front of them. Anytime a request comes to, let's say, api.100xdevs.com, it hits the load balancer, which sends the request to one of these backend servers to handle. That is how we have done backend deployment until now. Now you could run the application directly over here. You could run node dist/index.js, or you could have a Docker container running that has a port mapping so that the request that's coming is going to a Docker container. Doesn't matter what you deploy here or how you deploy here. This is how we've been deploying for a while now. Even in more easier terms, we've also deployed like this. You don't need a load balancer. We have a single EC2 machine. Any request that comes to app.100xdevs.com, let's say, or your website.com, it directly hits your server and your server is what handles it. This is how currently app.100xdevs.com works. If you go to this website, this request goes directly to an EC2 machine. If you ping app.100xdevs.com, what do you see? You see an IP of a server. This is not a load balancer. Unless you have a very big application, you don't need a load balancer. You don't need a lot of servers handling your requests. You can have a single server. We have a single server right now. If I go into the server, if I go SSH, my key, Ubuntu at the rate of the IP of this server, then I can actually go into this single machine that exists where all of the requests go when someone goes to app.100xdevs.com. If you look at it, I was able to SSH into this machine. The IP is the same as the IP that comes when you go to app.100xdevs.com. And if I go here, you will see there is a folder called CMS, which is hosting our code, and we are running it directly on the machine. Very simple, naive way to run applications. We have many classes in which we have discussed this. How do you deploy a Next.js application, Node.js application on the internet? You can do this for a front end as well. For example, if you have a Next.js application, you can have it hosted on a single machine where the user is sending requests. Or if you remember, we had a class where we discussed how to deploy front ends on AWS, where we said, if you have a React application, in the end, a React application is just a bunch of HTML, CSS, and JavaScript files. You write a lot of code, but that gets converted down to HTML, CSS, and JavaScript files. So rather than hosting these files on an EC2 machine, and whenever a user comes returning them back index.html, rather than doing this, we said, you can take all of these files and deploy them on an object store like S3. And whenever a user tries to request your website, for example, on mywebsite.com, you take this request. The request goes to a CDN, a content delivery network, which forwards it to S3, gets back the response, caches the response, and returns it to the end user. You don't even need an EC2 machine over here. You can simply expose the files over an object store, just like you would a video. If you HTML, CSS, and JavaScript are just files. This is just a file on a server that looks like this: index.html, index.css, file, or script.js. It's just files that you can store on something like S3. And whenever a user comes to your website.com, you can return them that file. That's exactly what happens when I visit a website, right? If I go to exceladraw.com, what happens when I press enter over here? If you go to the network tab, it gets back a bunch of files. It gets back an index.html file, a font file, a CSS file. So why not store them directly over here and return them to the user? These are the three ways we have deployed front ends until now. Number one, a very complex backend that you want to auto scale. We created an auto scaling group where we had multiple backend machines. We put a load balancer in front. Whenever a user sends a request comes to the load balancer and it goes to one of these two machines. What is the class for this? The class on auto scaling groups is where we discussed this architecture. Then we did, if you have a simple application, you don't want it to auto scale, you want it to be stored on a simple machine, you can simply start your application here, npm run dev, and then whenever a user comes, they're directly hitting your server. You don't need a load balancer to be in the picture because there is a single machine that's handling all the requests. And lastly, a slightly more, I wouldn't call it complex, but the right way to host React frontends is to host them on an object store like S3 and expose them over a CDN like Cloudflare. Again, we have a class on this in which we deep dive. The class is called deploying frontends on AWS. This is how you would deploy applications before Kubernetes. Now let's understand, how does this architecture change if you bring Kubernetes into the picture? How do you deploy applications on a Kubernetes cluster? What even is a Kubernetes cluster and how do you create one? After Kubernetes, your front end, back end, whatever you have deployed are all pods in your Kubernetes cluster. Now we have introduced two new terms, a pod and a Kubernetes cluster. Let's try to deep dive into just these two terms for now. And eventually there is a bunch of jargon we need to discuss. But before that, let's understand how do you deploy applications if you want to deploy them using Kubernetes. Number one, you create a bunch of machines on Amazon. You go to Amazon, you start 5 EC2 machines, or let's say you start 4 EC2 machines. You say, this will be my Kubernetes cluster. What does cluster mean? It means you're clustering a bunch of machines together. You start 4 machines and you start Kubernetes on all 4 of them. Before you deploy any backend code, any front-end code, anything at all, you install and start Kubernetes on all 4 of these machines. Whenever you are starting Kubernetes, you can start it in 2 modes. Let me quickly take you through this. This is important before we proceed at all. Sorry about that. There we go. Whenever you want to deploy using Kubernetes, you first start a bunch of machines and you call these machines a cluster. Okay, bhai, I have started my Kubernetes cluster. I have 4 machines. 4 machines are enough to handle all of my load. Sometimes I might have a lot of backend load. Sometimes I might have a lot of front-end load, but I know 4 machines are enough. When you start these 4 machines, some of them you start as workers. I repeat, some of them you start as workers. Let's say worker 1, worker 2, and worker 3. And some of them you start as masters. Whenever you're starting Kubernetes, you have to create this distinction. Okay, this is my master node. You could have multiple master nodes. You don't need one. But one is good enough for a cluster of this size. If you have 4 machines, you probably need 3 workers and 1 master. What is the goal of the master? The goal of the master is, I am listening to you, the developer. If this is the developer talks to the master. The developer tells the master, please find this backend image on Docker Hub and please start 2 versions of this. Please start 2 containers of my backend image on Docker Hub. And then the master, under the hood, there are a bunch of things that happen here. We'll be discussing them very soon. There are a bunch of components that the master has. But what is the goal of the master eventually? It is to make sure that these 2 containers deploy on some workers. It can decide, I have 3 workers to choose from. I think this and this are the least loaded right now. So I will start the backend container here and the second backend container here. That is the goal of the master. It takes requests from the user. The user can tell, now scale this up. I need 3 machines now. And then it will start backend here as well. Then the user can be like, no, sorry, scale this down. I only need 1 machine now. And then the master will be like, I'm going to delete this. This will be the only container that stays alive. So what does the master do? It takes instructions from the developer, and based on these instructions, somehow in the system, those containers get deployed. And what does the worker do? As the name suggests, this is the worker. This is where the actual container runs. What is happening when you want to deploy your application? In the end, there is some node dist/index.js running, right? There is some process that you're trying to run on some machine. But now you don't have to SSH into a machine and start it. You just have to tell a master node, please start this image on and start 5 versions of it. The master node will figure out what are the best machines to deploy them and start all 5 of them. This thing that the master node starts is what's called a pod. So what have we learned? What are the 2 jargons that we have learned? A Kubernetes cluster as well as a pod. What is a Kubernetes cluster? A bunch of machines where you have started Kubernetes. You have taken the source code of Kubernetes, you have started it. When you are starting it, you have told, you are the master. You will do all the master related things. You are the workers, you will be. The master will tell you somehow, or you will pull from the master, I need to start the backend process here. And then you need to actually run the backend over here. That's what a cluster is. All 4 of these machines are what are called nodes. So there are 2 jargons we have learned. A Kubernetes cluster, which is made up of 4 nodes, which is running 4 pods right now. What is a pod? It is not exactly a container. A single pod can run multiple containers, but it is the smallest unit that you can run. The developer will tell, please run a backend container. So you will run that container inside a pod. It is a small unit inside which you can run multiple containers, or if you want, a single container. Do we high level understand pods, cluster, and nodes, these 3 jargons? Let's do a quick poll. Oh wow, we don't. 64%. It's okay. We will take a breather. And we will open Q&A. Are pods and containers different? Yes. A single pod can run multiple containers. If this is a node, it can have a pod which is running both a front-end container and a back-end container. So a single pod can run multiple containers. A pod and a container are different things. Let me reshare screen. Looking at Q&A, if this is jarring, which it is, 64% is probably the worst I've seen ever a poll. If the intro itself is jarring, things from here is going to be a little more difficult. So let's spend some time here. Explain pod again. Screen share, recap, pod. Okay. Let's go back to the pre-Kubernetes days. If this is an EC2 machine, and let's say you want to deploy an application there, what would you do? You would first install Docker. If you want to do it in a containerized fashion, you would first install Docker, and then what would you run? Docker run some image underscore name. This is the command that you would run. When you would run this command, what would start? A container would start, right? A container would start. If I would run Docker PS after this, it will show me there is one container running. Just how a container is the execution unit in Docker. When you want to start something, you start a container. In the Kubernetes world, when you want to start something, you don't start a container, you start a pod inside which you can start multiple containers. Now you might be like, my every pod will run a single container. Then you can say a pod and the container are the same thing. In Kubernetes, if you are running, just like you run Docker run image name over here, here you will see we will run Kubernetes start image underscore name. This would start a pod. Now that pod is going to run a single container. So you could totally say the pod over here is the same as a container over here. Technically, this isn't a true statement. A pod over here can have multiple containers, but if you want to just a one-on-one comparison, then how do you start a Docker container? You do Docker run image name. How do you start a Kubernetes container? You do Kubernetes start image name. This will start a Kubernetes pod, which as you can see is, very similar to a container here, but not technically true because a pod can run multiple containers. Let's look at a little more Q&A. If pod is there, what is the use of container? Pod is just an abstraction. I am a pod. I am running 2 containers. The container is the actual thing that starts. This is a Docker container. This is a Docker container. The pod is just, I own both of these containers. I have started both of them. But the container is the thing that's actually executing. This is the Docker container running. This is the Docker container running. They are just abstracted in a pod. This pod is running both of these things. Think of a pod as a small machine inside your node, which can run multiple containers. Maybe that's a better way to put it. A pod can be thought of as a small machine inside your big node, which can run multiple containers. Pod is a subset of a node. Pod is not a subset of a node. A pod is something that runs inside a node. Pods are inside nodes. That is correct. In fact, if you really want a better picture. This is a cluster which has a bunch of nodes which run a bunch of pods inside which there are multiple containers. And what is a container running? A container is running an image that it pulled from, let's say, Docker Hub. So there are these layers of things that are happening. There is a cluster which has multiple nodes. A node can have multiple pods. A pod can have multiple containers, and a container runs a specific image, very similar to how you've been running until now. What is a worker? Worker is an EC2 instance. Yeah. There are two types of machines that you can start. Whenever you start an EC2 machine, you start Kubernetes over there. You run something like /Kubernetes type worker, something like this. You tell the machine that you are a Kubernetes node now and you are a worker, or you tell it that you are the master. A node is just an EC2 machine that's running Kubernetes right now. Pod versus cluster. Okay, so let me write down all the jargon at one place. I think this is right. Cluster, node, pod, container, image. Do we understand it now based on this image? Let me repeat this. Let me make this a little more cleaner. If you have a very big company, you will have a very big Kubernetes cluster. You will be like, okay, there is an EC2 machine here. There is an EC2 machine here, so on and so forth. All of these are what? These are nodes. But whenever you start a cluster, you have two types of nodes. You are either a master node. Let's say I create another one. This one is a master node and everything else is a worker node. EC2 node, master. A cluster has multiple nodes. A node, specifically a worker node, one of these three, can start a pod. It can start multiple pods as well. And inside each pod, you can run multiple Docker containers. We will be doing this very soon. We will create a cluster. We will create various nodes, a master node and a bunch of worker nodes. Once we create both of them, we will deploy an application there, a pod over there, which will start a container. That might make this a little easier to understand. But let me recap once very quickly. What all do you need? What all do you need when you don't use Kubernetes? When you don't use Kubernetes, you just start an EC2 machine. You go into this machine, you run docker run my_backend, and this starts a container. Life is simple. No fancy constructs, no cluster, a simple machine, a node, and a container running inside the node. But Kubernetes is a container orchestrator. It will run containers in various machines. It needs access to a pool of machines, especially if you have a very big company. So you will first start a bunch of nodes. Even before you start a pod, just cluster and node. You start a Kubernetes cluster, which is nothing but a bunch of EC2 machines that are running, for example. And then whenever you want to deploy something, you tell the master node, okay, hey, I want to deploy this backend image. I want 3 copies of this running, and this backend node, this master node starts 3 containers or 3 pods more specifically, which are running the backend container that you gave it. Do we now understand this specific architecture? A cluster, a node, pods, container, and image. Let me do a quick poll one more time. Okay, 88%, 85% is good enough. Not great, but we will be very soon starting these locally. We will start a bunch of nodes, deploy some pods there. So just keep these in mind. Thankfully, this is good enough for today. We won't be needing more jargon today. So try to digest just these 5 statements. Let me quickly recap these jargon here as well. Nodes in a Kubernetes cluster, you can create and connect various machines together all of which are running Kubernetes. Every machine is known as a node. There are two types of nodes. The master node, which is nowadays called as a control plane, and the worker node. You don't use the master term anywhere because of Black Lives Matter. So this is more popularly known as the control plane rather than the master node. It used to be called the master node. Inside the master node, there are a bunch of small things that run. I will quickly take you through them. You don't have to worry about them. If you don't understand them, it's fine. Even if you understand just this much for now. Okay, there is a master node where the developer interacts and tells, okay, please start two nodes of mine or two pods of mine. That is a master node. And where the pods run is the worker node. Even if you understand this much, it's great. But under the hood, how does this happen? For that, it is good to know, and you should definitely know this if you want to be a Kubernetes engineer, there are some certification programs that happen in Kubernetes. If you want to succeed in them, you should definitely know the internal architecture of a master node and the internal architecture of worker nodes. Let me take you through them really quickly from the top. If you don't understand, that's fine. If you do, even better. That's why I've created them in toggles so you don't get overwhelmed with everything that's inside here. But if you open the master node toggle, you will see inside the master node, there are a bunch of processes that run. What are these processes? Number one, the API server. This is the most important thing to know here. Everything else, if you ignore for now, it is fine. You should eventually understand, okay, what is a scheduler. You don't need to, if I'm being honest, for a long time or at all, if you're just using it to deploy applications. But if you want to understand the internals of Kubernetes, or if you want to be a core, Kubernetes engineer in a company like VMware, for example, then you need to understand each one of these. API server is the most important one. This is where you send requests. The developer tells, right, okay, please start a pod, please start a backend pod, please start a frontend pod. The developer is just sending an HTTP request to this API server that is running on the master node. This API server's job is to, number one, expose an HTTP server that developers can hit. For example, this HTTP server is hit by multiple things. It's hit by some of these processes as well. But if you don't worry about the internal talk between these processes, as a developer, you use this API server to tell it, please start a container. So what does the API server need to do? Number one, it needs to check, do you have access to this node? Are you trying to access the things that you have access to? Are you sending in a password along? Who are you that is trying to create a container, for example? And if those tests pass, it does authorization checks basically to make sure you are the right person to send a request. And then when it does receive something like, a pod needs to be created, it puts it in something called the etcd. This is very similar to Redis. It's a key value store, a place where you can, it's like a database, but the thing about this is it's a distributed database compared to Redis. Redis runs on a single thread. How have we discussed Redis in the past? Okay, it runs on a single thread on a single machine. You can put data in there. Okay, put username Harkirat, and then you can fetch data from here, for example, get username, and this would return you Harkirat. It's a key value store. etcd is very similar, but it's a distributed key value store. What does distributed mean? It means if you have multiple master nodes, they can share data amongst each other. If one master node puts something here, another master node can pull from it. Why do you need a distributed data store? Because when you tell the API server, start a pod, it will put this data here. A pod needs to be started. Then someone else from here, maybe this kube control manager, will understand a pod needs to be created. So it will try to put some more data in there. A pod needs to be started. So let me schedule this on a specific node. This is done by the kube scheduler. The kube scheduler will keep on infinitely running and checking, is there a pod that needs to be started on a machine? Yes, there is. Let me find a node where I can start this pod, and it will store that data here. This specific pod that the user wanted, let's start it on node number 2. And then eventually the node picks it up. We will understand that when we reach the node architecture. But to recap, what are the 4 things here? API server, the most important thing you need to worry about. If this is your Kubernetes cluster, which has 4 machines, worker 1, worker 2, worker 3, and then one master, let's say. This master will have an API server where you, the developer, will send a command like, please start backend of my docker hub.com/100xdevs/image_backend. Please create 2 copies of this. Please run both of them on one of these worker nodes. You will send this request. API server will check, is this fine? If it is, it will store this desired state. What is the desired state now? Okay, 2 of these need to run on some of these workers. We need 2 containers to start. It will store this desired state in etcd, which is a key value pair. It will store something like this. Okay. Pod1 has this image_backend that needs to start, and then pod2 has this image that needs to start. Then there is a third process here called the scheduler, which will keep checking etcd. It will keep hitting the API server to check, is there a pod that is not yet assigned a node? It will run an infinite loop to check, is there a pod that's currently pending? Is there a pod that's currently pending? And it will find, there are 2 pods that have not yet been assigned a worker. So it will assign a worker to them. Here you go to worker 1 and you go to worker 2. That is what the scheduler is supposed to do. These are the 3 components that are good enough. There is one more component, which is, what's it called? Controller manager. Again, if you don't understand this the first time, it's fine. We'll be writing some code very soon, and that might, where all of this will be abstracted. You won't have to worry about any of them, but these are good to know. There is more detail here if you want to, read through them yourself, what each one of them does. The controller manager, before we dive into this, we need to understand what a controller is. A controller is basically an infinite loop that's running. That's what a controller is. The scheduler is also a controller. It's infinitely checking, is there a pod I need to assign? And similarly, controller manager runs a bunch of smaller controllers. Yeah, don't even worry about this, if I'm being honest. It'll just be too hard to explain until we understand pods and deployments. But let me give you a brief of what this does. Controller, job, controller, replica set controller. It just starts it runs an infinite loop and checks, does the deployment controller need to do something? Harkirat, what is the deployment controller? Don't worry about it. We'll get to it eventually. Does the job controller need to do anything? Does the replica set controller need to do anything? And if it does, then, basically runs a bunch of controllers. That's why it's called a controller manager. It manages a bunch of other controllers. Now, what are these controllers and what do they need to do? Don't worry about it. Once we reach deployment, once we reach replica sets, we'll understand what are these controllers and what they do. That's a brief of the master architecture. That's actually good enough to know if you understood everything. I'm sure you did not, and that is fine. I never understood this, never wanted to even dive into this. I dived into a bunch of this just for the class. The API server is the most important thing to know. Okay, the master has the API server. You talk to the API server, and then all the other things that you see here is how your pod eventually reaches a worker node. You just told the API server that something needs to run. That thing going to a worker node 1, worker 2, node 2, worker node 3 is done by all the other things that you see over here. The scheduler is what finds a node for it. etcd is a database that Kubernetes uses to store the desired state. Currently, how many pods need to run. And the controller manager runs a bunch of things. This one just ignore for now. Controller manager and cloud controller manager are two things that are good to know, but like not right now. Maybe in a few weeks, if need be, we'll dive into this. Don't even worry about this for now. Maybe at the end of the class, we can discuss as well. That is the architecture of a master node. Worker node also has a bunch of these, components that run. I'm going to quickly take you through them. The most important one is the container runtime. When you start a worker node, what is its job eventually? To run a bunch of containers, right? Container 1, container 2, container 3. This specific container runtime is where those specific containers run. That's the most important thing to know on a worker node. But to be able to put containers here, you use something called a kubelet. A kubelet is a process that keeps on running on a worker node that pretty much checks. There is a process that runs over here on a worker node, on every worker node called the kubelet, that checks, is there a pod I need to deploy? This is also a controller. Infinitely will keep checking. Is there a pod I need to deploy? Is there a pod I need to deploy? And if there is, it will deploy it where? On the container runtime. These are all very low level details that you don't understand now, forever, it's fine. But it's something that we have to discuss. Kubelet is a process that hits the API server on the master to check, do I need to run something? Who schedules a pod over here? The scheduler does. The scheduler puts in etcd, this pod will run on this node, and then the kubelet that's running on this machine checks the API server, is there something I need to run? Is there a new pod I need to run? And if there is, it starts the pod over here. Lastly, there's something called the kube proxy, which handles how you can eventually send an HTTP request to this process. Whatever process is running over here, it is running inside so many abstractions. There is a node which has a pod, which has a container. How do you eventually reach that container is where the kube proxy comes into the picture. Again, there is more details here, but let's take a pause and take a breather, and let's start a little bit of coding. Let's start some containers. Let's start some pods. Let's try to discover them, and then maybe come back to this slide to understand these things a little better. To recap, what have we discussed? What is the jargon we have discussed? Nodes. All the machines that you see over here, each one of them is a node. Nodes are of two types: a master node and a worker node. Cluster. A bunch of these worker nodes and master nodes together are what are called a cluster. Images, this is just a Docker image, for example, that you've deployed on Docker Hub. Containers, very similar to the container that we've been running in the past using Docker Run. And lastly, pod. A pod is the smallest and the simplest unit in Kubernetes that you can create or deploy. You can deploy a pod which could be running multiple containers inside. That is a brief enough architecture. Let's dive a little bit deeper into how you can start a container, deploy an application there, and eventually come back to it. Come back to a bunch of these, lower level details. Let me do a poll. If you don't understand, it's fine. I'm sure not a lot of people do right now. Let's do a quick poll. How are we doing? Good, bad, decentish. 71%, 70%. So 70% are doing okayish, 32% are doing bad. We can come back to the architecture and internals. Let's not go there. Where should we focus? Starting a bunch of these nodes and starting an application there, because there are a few things to understand before you start, a Kubernetes cluster or deploy an application there. So before we can actually start deploying, you need a Kubernetes cluster. You need a bunch of machines deployed that are running Kubernetes. You can do that on cloud using Google Cloud, Amazon, Vultr, or you can start it locally. The reason I mentioned Vultr here is because they give $200 of credits. So if you want to have one handy by tomorrow, just get those credits and try to deploy a Kubernetes cluster here. You can also deploy it locally, which means start a bunch of mini machines locally. Start a cluster that looks like this. It has 3 workers and 1 master locally, just to test things out and emulate a Kubernetes cluster. For that, there are 2 popular tools. There are many actually. There's a third one as well. I forgot the name. Minikube is the most important one. The most old one, not important one. The one that I used to use up until recently. This is named incorrectly. It's Minikube, Minikube. Or there is Kind. Kind stands for Kubernetes inside Docker. I would go with Kind because it lets you create worker nodes and master nodes. Minikube only creates a single master node that acts as both the worker and the master. Kind lets you specify, I need 3 worker nodes, 1 master node. So step 1 for everyone here, if you want to try this out, is to install kind on your machine. What does kind stand for? Kubernetes inside Docker. What does that mean? It will let you create a cluster like this. It will let you emulate a cluster like this, which has 4 machines. 1 of them is a master, 3 of them are workers on your own machine by creating 4 Docker containers basically. Though 4 Docker containers would act as 4 Kubernetes nodes. So kind is the easiest way to do it. Minikube is actually easier, but kind is the right way to do it because you have worker nodes as well as master nodes. Installation steps should take a break. We're at 7:55. Wow, already an hour has gone by. Let's take a 5-minute break. Until then, try to install 2 things. Try to install kind and try to install kubectl, which I think is in the next slide. Next to next slide. So there are installation steps for kubectl over here. Try to install that as well as try to install kind over the next 5-10 minutes. Let's take a small break and let me answer some questions from chat. Going to open chat. Jarring, so it's Kubernetes, my friend. It's the most difficult thing we are doing in the cohort. We can go slower / more beginner friendly. I'm open to it. All right, let's see. Kubernetes does not deploy. Instead, the container is encapsulated. What is the pod? Don't we need a load balancer once we have Kubernetes managing pods, machine load? You do need a load balancer if you have a Kubernetes cluster. This is a slightly advanced concept that will come eventually. If this is your cluster, right, where you have multiple worker machines, you do need a load balancer if your application is really big. But that load balancer, a lot of time exists outside the container. You have an AWS load balancer. This is where what were the 2 types of control managers that I said exist on a worker node? On a master node. If you go back to the architecture, the master node, I said, there is a kube control manager. There is also a cloud kube control manager. The thing about Kubernetes is, these guys said, some things can be cloud agnostic. Jisko node banana hai, doesn't matter. You make it on EC2 machine, you make it on GCP, doesn't matter. But some things are cloud specific. Like a load balancer, AWS will have its own implementation of a load balancer. If you go to the AWS dashboard, you can go to load balancers and see one. Similarly, GCP will have its own. So it also lets you create things like load balancers outside your cluster. You can use Kubernetes to provision things like load balancers outside the container, outside your cluster. And yes, it's a popularly used use case. If you have multiple nodes and multiple pods, you might have a load balancer here. Does container runtime contains pods in which the image is executed? It contains the container. What is it called? A container runtime. So what does it run? It runs all the containers that are being executed. Couldn't install kind. If you can't, then try Minikube. If you do install Minikube, then just run Minikube start. And that should start a Kubernetes, not a cluster. It'll just start a single node for you. But you have a few more minutes, try to install kind. Understood pod. But what is the need of a pod? Why can't you just run containers directly on a machine? Are containers not isolated enough? They are isolated enough. But a lot of times you might want, this is my full stack application. My full stack application has a front end and a back end, and maybe a back end too as well, which are all connected via an internal Redis. If you have a system like this, there is backend 1 and backend 2 that communicate via not a global Redis, an internal Redis that you want them to communicate. Only these two use this Redis. No other process uses it. Then a pod would let you run all of these together, let them talk to each other. They can discover each other very quickly. Everything inside a pod shares the file system, can, talk to each other easily, compared to if you have, two separate pods. So if there was no concept of a pod, then, you would have had to set up a bunch of things. The second pod, the whole point of a pod is you can run multiple containers inside it. If you take that away, that means every pod has a single container. That means, you cannot run multiple processes on the same pod. So that's sort of the benefit. I get that container is a good enough abstraction. Why do you need something on top of it? The answer is, if you want to run multiple things and let them share the file system, talk to each other, is when, a pod makes sense. Of course, and most of the times you don't do this. Most of the times a pod is running a single container only. So that is why, it's not the most used use case of a pod, you're running multiple containers inside, but that is what it provides you. Okay. It is not for someone asked, why do you need pod abstraction over containers? It's not for the fact it makes it easier for the API server. It's just for the fact if you want to deploy multiple containers that can talk to each other, share the file system, things like these, then, a pod lets you do it. Versus then, Harkit, why don't you make all the containers share the file system? I mean, I guess the question is, why do you need a pod when a container is good enough? And the answer is, when these container runs, sometimes container 1 runs on one machine, container 2, or I found a good reason, like a good explanation for, why do you need a pod? You have 3 worker nodes, and let's say pod does not exist as a concept. There are only containers. Then let's say you want to deploy an application which has, backend 1 and backend 2 that need to share the file system, let's say, or that need to talk to each other. If they were separate, then, Kubernetes might schedule one over here, might schedule the other one over here. They cannot share file system. They can still share a file system by using a networked file system, but you get the idea. They can't share the file system of this machine. Versus if pod exists as a concept, then you can be like, this is our pod that runs 2 containers. Then they would never go on different machines. This pod would either come here, or there might be another replica of it that might come here. But the point is, they can, whenever these 2 containers are running, they can talk to each other much easily compared to if pod wasn't a concept. If pod wasn't a concept, then backend 1 would run here and then backend 2 would run here, or could run here. I mean, they could run the same machine as well, but could run different machine as well. We're at 8:02. Let's take 3 more minutes of questions, then we'll go. How does Terraform come into the pic? It does not come into the pic here. Terraform is for something else. It's infrastructure as code. It can let you create a Kubernetes cluster in the form of code. You can write a file that looks like this. I need a Kubernetes cluster on AWS with 2 masters and 5 workers. And then you can run a command like this, Terraform apply, that would create these nodes for you on AWS. That is what Terraform does. You don't need Terraform for Kubernetes, just like you don't need Terraform for creating EC2 machines. You can use Terraform to create AWS instances. You can use Terraform to create Kubernetes clusters, but you don't need to. Okay, someone asked, Harkiyat, when you submit a question on lead code, can you explain this a bit in the context of Kubernetes, pods and containers? You won't learn much about pods and containers if you want to understand the lead code architecture, but anytime someone comes and sends you a request to, /submit, you will most probably start a pod over here that will run their code. Now this pod will run a single container. If there is a C++ processes the user started, then this pod will run some CPP container. The code will get evaluated. The code will get returned to the user. The reason you might want to run this in a pod is because they're very isolated, right? If this pod dies, if this pod crashes, you're fine. Your cluster is still fine, but the benefit remains the same if it is a container. There is no benefit, or like you don't need Kubernetes plus a pod for lead code. Docker plus a container just works. There is nothing extra that Kubernetes gives you, other than maybe some auto scaling constructs. But you won't get any extra security if you run it on a pod compared to you run it on a Docker, run it as a Docker container. Cool. 8:04, let's take a breather here before we start. One more minute. Let me do a quick poll. Are we doing good, guys? If you should understand some high level pods, nodes, cluster by now. If you understand that much, you should be fine. Okay, well, pretty good. Okay, 85%, surprising. All right. Hopefully some of you have installed Kind. If you haven't, that's fine. You can just look at the screen and eventually install it. What does Kind let you do? It lets you create a Kubernetes cluster locally. Let's see how can you do that. Let's write the command kind create cluster -- name local. What is the command that we're running? You can run it anywhere. Kind create a Kubernetes cluster and give it a name called local. Before you do this, you need to make sure you have Docker running on your machine. If you don't have Docker, it won't work. The name itself is, Kubernetes inside Docker. So you need to have Docker running, installed as well as running. All right. It happened quickly for me, might not happen as quickly for you. It might be pulling the images it needs for you if this is the first time you're running this command. So I'll wait for a bit. But after it is done, you can run this command, for example, kubectl. Okay, don't run kubectl yet. You don't have kubectl. Just run this command, kind create cluster, give it a name local. Wait for it to succeed. It might take a long time for you if it's downloading the image. But once it does, run docker ps. And notice, ignore all of these containers that I have. Let me just kill them. These are from last week. They're just still running. All right. After you've run kind create cluster and given it a name, you should see a Docker container that has started. And what is the name of the Docker container? It's called local control plane. What was control plane? The master node. It means you were able to start a master node on our machine. But Harkirat, you to said Kubernetes cluster contains one master node or multiple master nodes, as well as multiple worker nodes. Where are the worker nodes? That's a great point. As I said, you can actually suffice with just a master node. The master can act as a worker. But that's not ideal. That is what Minikube gives you. What are the two tools you use to start a container? Kind or Minikube. The whole benefit of Kind is it lets you start a multi-node cluster. Let's see how you can do that. How can you start not just a single, but a multi-node cluster? You can create a file. Now here is where I'm going to introduce YAML. I hope we know YAML by now. We have done this many times. When we were deploying a CI/CD pipeline, we saw a .yaml file. What is a .yaml file? It has a bunch of key value pairs. Okay, kind, the value of kind is cluster. API version, the value of API version is this thing right here. Nodes is an array which has 3 values. If you copy this, if this feels a little jarring, your YAML file I cannot understand, you can go to a YAML to JSON converter. Put the YAML on the left and it'll give you the same thing in JSON on the right. If you understand JSON better, then you can convert this into this and understand, acha, this is just a key value pair. Ke kind is cluster, API version is this thing, and nodes is an array of 3 values: role control plane, role worker, and role worker. Can you understand where we might be going with this? I've created a config file that is going to tell kind, please start 1 master and 2 worker nodes. So if I create this file locally, let me call it clusters.yaml. And if I paste this configuration over here, and now if I run, what's the command? Kind cluster create and give it the configuration file as a flag. It'll probably tell me I probably need to delete the cluster first. So let's first do kind delete or kind cluster delete. Kind delete cluster. That should delete the cluster that we had just created. And now try to recreate it by running the command kind create cluster dash dash config. Give it the path to your YAML file and then give it a name. Let me give it a different name. I wasn't able to delete my local cluster, so I just give it a different name called local2 for now. While this runs, let me ask, how many of you are actually trying this out locally as well? Oh, 50-50. 40-60 actually. All right, what is the command that I ran? Kind create cluster, but this time I gave it a configuration file. What does the configuration file look like? It's basically tells it, here you need to start three things. You need to start a control plane, you need to start a worker and another worker. You need to start a master node and you need to start two worker nodes. Now if I run docker ps, you will see, ignore the old one that was running. I now have a new cluster which has one master node running and two worker nodes running. It also tells me, KR, you can go over here to hit the Kubernetes API. If you remember, what did the master node expose? The master node exposed, amongst the many things it had running on the machine, it had the API server. And how can I hit this API server now? How can I start to tell it, KR, please start a pod? I can use this URL right here. The only thing is you have to go to HTTPS and not HTTP. But if you go here, you can see I can start to hit the API. Now I don't have any access to it. I'm not sending it any password along with it, which is why it tells me if forbidden user, I cannot hit this specific / path. But if I send it the right credentials, it'll give me back some details. I can now interact with the Kubernetes API. To recap, what have I done? I first ran the command kind create cluster that started a one node cluster for me. I don't want a one node cluster. I want a 3 node cluster. And hence I first created the clusters.yaml file. I put 3 sets of nodes that I need there. I need a control plane, the master node, and I need 2 worker nodes. Then I restarted I started a new cluster called local2. And here I gave the cluster.yaml file as an input. By the end, I was able to see 3 containers that are running. This is my master node. These are my worker nodes. And now I can also hit the API on the master node. It's not returning me anything right now because I don't have any access. I'm not giving it any credentials along. But at least the API server is running. There is something running on this master node that I can interact with. Let me also delete the other cluster. There you go. Deleting cluster local. Now if I run docker ps, you can see I only have 3 containers running, master node and 2 worker nodes. Question is, how can I tell this master node to start a pod? How can I interact with it? When I started to interact with it, it so told me, okay, bro, sorry, you are forbidden. Even if I try to send it a request like create pod harkirat_image, it'll just keep telling me forbidden user, you don't have access. So where are these credentials of mine stored? I just started a container, but where are these credentials? How can I connect to them? Even if I went to AWS right now and started to create a new Kubernetes cluster, the way to do the same in AWS is you can go to Elastic Kubernetes service and you can create a new cluster. When you create this new cluster, it will give you some sort of a password, right? As long as you have this password, you can connect to the API server. You can talk to the API server. Where is that password stored? And even if I go here on AWS and create it, where will on my machine I store that password so that I can connect to it? And the answer is this file called .cube/config. If you try to look at the contents of root folder /.cube/config, this is where you store all of your Kubernetes config, which means what cluster are you trying to connect to and what is your password to that cluster. Whenever I go to AWS and create this cluster, this will give me something that I will put here in .cube/config, so that now when I try to interact with it using a certain command line interface, using something called kubectl, this command line interface will first go here, find my credentials, and then send a request to the API server with these credentials. I will repeat all of this. Let me go back to the slides. We have been able to create a Kubernetes cluster, but when we were creating it, right, there was some credentials that kind stored for us, this thing that we use to start the container, stored for us here. If I do a cat.cube/config, you will see here there was this container that I had in Vultr that I was trying to connect to. I had a bunch of clusters that I have created in the past, and the config for them is over here. There is another cluster that I'm running locally. This is kind-local2. And here, these are the credentials for me to be able to connect to it. You don't have to understand all of this. The point is these credentials, these secrets are enough for me to connect to this cluster. Whenever I'm sending a request here, I need to send some extra password, authentication details, and only then can I hit this server. Where is this authentication detail stored? It's stored in .cube/config. If in the future I create a Kubernetes cluster on DigitalOcean, DigitalOcean will give me a config file. KR, please replace your config file with this config file. It has all the secrets that you need to be able to connect to this Kubernetes cluster. So step one is filling this config file. Thankfully, Kind already did it for us. If you can see, there is the context of this server kind-local. So there is already that information here, kind-local2. This is the one that we created, right? What was our container called? It was called local2. The credentials of that are already here. Question is, how can I interact with this API server and send the config along and send my password along with it? And the answer is by using this command line interface called kubectl. So you need to first install kubectl on your machine. Where can you find do you really need it? Harkirat, can I not simply go here and send requests? Yes, you can go to Postman and have this as your base URL. Figure out the endpoint that you need to have, /create /pod_name. Figure out what headers you need to send along based on the config file, and then send a request from here. You can do that, or you can use this command line interface called kubectl that automatically picks your configurations from here and sends a request to the container. Why is this cool? Because now you can simply run commands like this here. Kubernetes or kubectl create pod, and give it the image that you want to start, for example. So what do you want to do? You want to first install kubectl on your machine. To quickly recap, what all have we installed on our machine until now? We have installed kind, using which we started a cluster locally. This cluster has 2 workers and 1 master node. And now we want to interact with this 1 master node, for which we need to install kubectl. Why do we need to install kubectl? Because it's a command line interface that automatically picks up your credentials from .cube/config before you send a request over to, whatever API server that this master node is running. The next step is installing kubectl. I'll give you guys 2 minutes. The instructions are here in the kubectl section. If you go to, that looks wrong actually, kubectl. There you go. Let me paste this in chat. Select your operating system. Oh no, there's something else actually. Install kubectl. There you go. This is probably the better place to look at. Install kubectl on Linux, Mac OS, Windows, whatever. If you're on Mac, I think it's as simple as, you have to do this. I thought it will be as simple as brew install kubectl, but seems like it isn't. Yeah, you can use brew install kubectl if you're on a Mac, or go through the whole thing. It's fine. 1 more minute. What do you have to have in the end? You have to have kubectl as a CLI available to you by the end. Most probably tomorrow we will recap this and restart by creating a container and connecting to it. Class was slower than I was hoping for, but this is an advanced concept, so it's fine. kubectl. Let me just show you a few commands, and you will eventually see them on your side if you're installing. Run kubectl get nodes, and it's giving me here you have 3 nodes. One of them is a master node, 2 of them are worker nodes. All of them are ready, and all of them started around 10 minutes ago. If you want to see what HTTP request is going out to the API server, you can add --v equal to 8, or the verbosity level. How verbose? What does verbose mean? How talkative the response of this thing needs to be. If you set it to 8, it will give you a bunch of things along with. This is the endpoint that they hit. Your API server endpoint /API/v1/nodes. This endpoint returned them a very big JSON, which it was able to parse and figure out that these are the 3 nodes that exist. So kubectl isn't something special. This under the hood is still sending an API request. Only number 1, it is sending your credentials along with it. Number 2, it is parsing the very big JSON response and giving you, if I remove the verbosity, giving you very clean outputs. You have 3 nodes running. You can still hit the localhost : whatever that endpoint is /API/v1/nodes. Of course, you won't be able to access it right now, but if you add the right headers, which you can totally, find the right credentials from here and send them along, probably not here, but in Postman, you can get back a very nice big JSON blob as well, and get the current lists of nodes. But if you use kubectl, it just makes your life easier. You don't have to know the actual endpoint. You just run kubectl get nodes. What is this command returning me? It is telling me I have 3 nodes currently running. This is my Kubernetes cluster, and it has 1 master node and 2 worker nodes. Now the question is, how do I start a pod on these worker nodes? How do I send a request to the master node or to the API server that says create a pod with this specific image_name? That's the next question. But before we get there, let me do a quick poll and understand. Are we good to go, guys? Shall I proceed, or do we have any more questions around kind or kubectl? This is more of a local issue. If you have questions, probably just you're not able to run this locally. But are we good to go? Shall we proceed? Okay, I will have to take a pause now. 70%. So let's take a pause for 8 minutes. Today's class, I'll answer a few questions for 8 minutes. Then I will show how to create a pod. Basically, we'll try to reach slide number 7, 8, 9, 10. We'll stop there. So today we'll just create a pod, and we'll understand about the manifest file that lets you create a pod in a slightly cleaner fashion. And we'll do a quick checkpoint. That's it. Today's class, we'll just do this one. So if you feel this is simple, already know this, don't want to waste 40 more minutes, feel free to drop off. By the end of today's class, our goal is to understand all of these and actually run all of these on our machines. But before I proceed, I will have to take a break and look at maybe chat. So let me open chat. Bunch of recaps and a bunch of questions. Let them flow. All right. Let's just finish. People can drop off. Okay, let's just finish the slides. Okay, that works. I guess that's better. Let me just finish the slides until slide number 10, so you guys can drop off and then I can take questions. I think that's better. So where were we? We were on slide number kubectl. You can eventually install kubectl on your machine. Let me finish the slides until slide number 10, and then I will just open it up for questions. So people who understand everything can drop off. This is how you get all the nodes. And by the same logic, can you guess how can you get all the pods? Kubectl get pods. And what does it say? It says no resources found in the default namespace. What is a namespace? We will come to eventually. But Currently, there are no pods running. We have nodes, we have machines, but we don't have any pods. What does our current architecture look like? It looks like this. Now I need to tell the API server, start a pod with this specific image name. How can I do that? There are various ways to do it. The easiest way is to run this command, kubectl run the name that you want to give to this pod, the image that you want it to run, and the port that this image has exposed. Even before you run kubectl, even before we start a pod, let's try to run the same image. This is the image that we're trying to run. It's a very popular Nginx image that you use for testing and also in production sometimes. It starts Nginx whenever you, what is Nginx? We've discussed a little bit. It starts a simple HTTP server. If you ever run docker run Nginx, it will start an HTTP server on port 80 of that container. If I ever run docker run Nginx, and this is my machine, it will start a container on which the container is listening on something on port 80. So if I run docker run -p 3000:80 Nginx, then my machine will start to listen on port 3000, and any request that comes here will start to go to this container. So let's start a Docker container locally first. How do I run it? Docker run -p 3000:80 Nginx. If I run just this much, it happened for me very quickly. Might take some time for you because I already had the Nginx image. If I now go to localhost :3000, you will see, I see this welcome to Nginx page. I'm not using Kubernetes at all. I'm just using Docker to start a container. I'm not starting a pod. I'm starting a container. The image for that container is Nginx. What does this do? It starts an Nginx server on port 80 of the container. Since I added a port mapping, KR Harkirat's Mac machines 3000 should point to the 80 port of the container. I'm able to visit this on localhost :3000. Notice all the logs that appear. Some Docker entry point sh, a bunch of started working process, a bunch of logs come. Let me stop this. If I stop this, container goes down. No Kubernetes logic, simple Docker logic. Even if I did not have Kubernetes running on my machine, even if I did not have kind on my machine, I can still run this and I can run an external image on my machine as a Docker container. Now, how can I start this inside the Kubernetes cluster? How can I start this Nginx container over here? The answer is, again, you can use kubectl. What do you want to create? You want to create a pod. Kubectl create pod. Like, let's see what the exact command is. Kubectl run Nginx. Give it a name. Give it an image. Let me just have the Docker command here. This was the Docker command. What is the corresponding Kubernetes command? Kubectl run. Give your pod a name. What image am I running? I am running the Nginx image, this thing right here. And what port do I want exposed on this container? It is port 80. We'll come to what this is later on. This much is not enough to expose your pod over the internet, but you do need this so that this port, there is something listening on that port, on that pod that starts. If I run this, it says pod/Nginx created. What has happened? A bunch of things have happened under the hood. A bunch of things have happened on the master. A bunch of things have happened on the worker. The worker had the kubelet, if you remembered. The kubelet has pulled an image, understood that I need to start a pod. And eventually a pod has started here. You as the developer only had to write this much. But under the hood, you sent an API request to the API server, which did a bunch of things, stored something in etcd. Then the scheduler came into the picture, assigned it a node. And then eventually the thing started on a node. How do I know that a pod is running now? I can run kubectl get pod, and it tells me, yeah, there is a pod with name Nginx 1/1, which means it is ready. It is currently in the running state, hasn't restarted, and has an age of 44 seconds. How do I know that this is running correctly? Can I go to a URL, Hakirat? No, you cannot go to a URL. You cannot go to a URL and actually reach this container. That is a whole different beast Okay, how can you actually discover a service? Then Harkiyat, how do I know if this is working? Well, what were the logs that came here? If I ran docker run nginx, I saw a bunch of logs, right? I can run docker logs nginx, docker, think there's a better name. Let's see. Sorry, what am I doing? kubectl logs nginx. And I see the same set of logs over here. What does that tell me? Okay, somewhere though this is running. I don't know where it is running. I don't know what worker it is running on, but somewhere the logs that came here are the same as the logs that come when you start nginx using docker, which means the pod has started. I cannot discover it right now. I cannot go to my browser and hit a URL and reach it, but it is running somewhere. If I run kubectl get pods, you can actually run kubectl describe pod nginx, and that will give you a bunch of details. Specifically, the detail that I'm looking for is what worker is it running on, and it is running on the second worker over here. What command did I run? Kubectl describe pod nginx. Describe the pod with the name nginx, and what is it telling me? It is running on worker. Local2 worker, local2/worker2, which means the second worker. What does that mean? That means we have been able to start a container or start a pod more specifically over here. I gave a single command to the master node that started a pod over here. Can I start another pod? Yes. You can totally run kubectl, the command that we ran. Kubectl run nginx, maybe give it a new name, call it nginx-2, which runs the same image on port 80. It says another pod has been created. Maybe try to create another pod for Postgres. Just how you run Docker commands to start Docker containers, you are running kubectl commands, which under the hood are sending a request to your API server, running on your Kubernetes master, and starting a bunch of these. If I do kubectl get pods, it shows me 3 of them have been created. 2 of them are currently running. The third one is in the container creating stage. The container is it is being created. It is not yet running. Most probably this will fail. If I do kubectl get pods-w, it starts to watch, which basically means, I don't have to keep running it again and again. If I wait for a few minutes, Postgres will most probably error out. The reason for that is whenever you're starting a Postgres container, you need to give it an environment variable. So this isn't enough. You have to send in a environment variable, which is the Postgres_password, and only then does it work. You can also, look at the logs of Postgres, kubectl logs Postgres, and it tells you, okay, database is an uninitialized super user, yada, yada. You must specify this Postgres password, and only then will it work. So it will keep on crashing now. But notice, even if this is crashing, there is something called restarts here. It will keep trying to restart this. You told me I have to start a pod. I will keep trying again and again to start this pod. I will not destroy this pod just because it crashed. That is just one benefit that Kubernetes provides you. All right, let's look at the slides. We've been able to start pods, and deleting pods is as simple as kubectl delete pod and the name of the pod. For example, the name of this pod is Postgres. Kubectl delete pod Postgres, and you can delete the rest of them as well. A great question to ask at this point is, Girat, you are starting these pods. Some of these pods are starting at this machine, some of them are starting at this machine, but you never showed me how can I reach this specific pod. How can I go to some local host some port and reach this specific pod? We'll get to that in a while when we reach services. The jargon that we have learned until now is cluster, node, pod, container, image, and that's it. The jargon that we are yet to learn, there is a lot of jargon things to learn next, but deployment, replica set, and then eventually we will reach services, ingress, config maps, and maybe a bunch of other, if we get the time, basically a bunch of other things. We're basically just here right now. And when we reach services is when we will understand how can you visit a specific pod, how can you send an HTTP request to it. Okay, that is all I had for today. Let's see. Yeah, one more thing before we go maybe. Okay, this is one way to start an Nginx container. Okay, you write the whole thing in a single command. You write kubectl run Nginx, the image that it needs to pull from Docker Hub and the port at which it needs to start. Or you can create a manifest file. What does a manifest file mean? A YAML file where you can describe all of this. Here I want a pod named Nginx. This is the metadata for it. This is the name for it. And this is the specification for it. It needs to run multiple containers. Containers is what? It is an array. We are just giving it one container right now, but I could give it another container right below it, and the single pod could then start multiple containers. You can create a manifest file like this. If you want to break down this manifest file, this is actually pretty interesting. Eventually, as I said, we will be creating deployments, replica sites, services, a bunch of other things. There are like thousands of these things you can create. You can create your own, whatever you want to call them, services as well. And whenever you do, you have to specify when was this specific kind of service introduced? When was a pod introduced? Pod was introduced in the very first version of Kubernetes. It's one of those base concepts that Kubernetes had right from the beginning. And hence, the first thing that you see here, API version, is this thing, where is this specified in Kubernetes? Is it in the first version? Or eventually when some different version came that introduced something more complex, is this kind present over here? So what does API version mean? Whatever you are trying to create, which in this case, I'm trying to create a pod, what version of Kubernetes can you find it at? And V1 is the answer here. The name that you want to give to this specific container or like pod that you're starting, in our case, is going to be Nginx, and the spec for it, the specification, what all containers do you want to start? And the answer is, we just want to start one container with this name. This is the image that you can find on Docker Hub. And these are the ports that are currently open on this pod. If I copy this and create a manifest file, where I paste this, now rather than, let me just delete all the pods. Rather than doing kubectl create Nginx, I can simply do kubectl apply -f and the name of the file. What is the command that I'm running? Kubectl apply -f and the name of the file. What does this file contain? It contains this specification for now. I want to start a single pod with these containers running inside, just the Nginx container for now. If I press enter, it says pod created. If I try to create the same thing again, it says pod unchanged. If I change this image name to something else, it will change the thing on the image that is being created /run on the final pod as well. If I do kubectl get pods, you see a single pod is running. That is a brief of how you can create pods. You can either create them directly, something like this, or you can create a manifest file where you describe all of this and then you simply do a kubectl apply. What is the benefit of doing this? The benefit of doing this is, as your application grows, you push more images to Docker Hub, then you can simply change this file in your CI/CD pipeline. We'll do this eventually when we add Kubernetes to our CI/CD pipeline. So when we do that, we'll see this image tag is what we keep changing. 100x backend or whatever, Facebook backend at the rate of a specific Docker tag. This image name keeps on changing, and we just keep on applying the same manifest again and again. And it says that image name has been changed. The new image goes to the new pod. The new pod starts. All that jazz. All right. Is there anything else in pods? No. This was a checkpoint after this. This is where we are at right now. We have a single control plane. We have two workers. One of those workers is running a pod, which is running the Nginx container. This container is running for sure. There is no way for us to reach this container right now. How can we reach this container is something we'll get to eventually. Tomorrow, we'll recap at least all of this actionable path to start a pod locally, and then we'll start with deployments and go from there. All right, take a pause here at 8:40. Going to open it for questions and anything else. All right, heavy class. Oh boy. If nodes are machine, how are you running machines locally? They're running inside a Docker. Can you not run Ubuntu on your machine? If you run a Docker, run Ubuntu, what happens? The container starts running Ubuntu, right? So it doesn't have to, it has to be a machine, but you can run Ubuntu or a different machine inside Docker. Docker lets you run containers, which can be, they're operating systems in themselves. So not operating systems themselves, but like they're containers where you can, for example, run, if you do a Docker PS, what are these three running? They're running this kind test / node image. And this image is good enough to simulate, a Kubernetes cluster for a worker node and for a master node and a bunch of worker nodes. Why using Kubernetes? After all, we have auto scaling in AWS. Yes. There are few reasons why you want to use Kubernetes. Number one, it becomes cloud agnostic. The biggest benefit of using Kubernetes is you can very easily move from one cloud provider to another to your own data center, because you just have to create a Kubernetes cluster. And you might have initially one on AWS. Yeah, this is my AWS cluster. AWS is doing great. This is where I'm applying all of my changes. Okay, kubectl apply manifest.yaml. But then AWS increased their prices a lot. So all that you have to do, now is create another Kubernetes cluster in, let's say, GCP. And then all you have to do is run a single command. All of your code will start to run here. You can also have a multi-cloud setup. You have some nodes here, some nodes here. This is your Kubernetes cluster. If AWS is ever down, digital GCP is up. If GCP is ever down, AWS is up. So if you want to eventually move to your own data center, you can do that as well. Yahan pe you're running Kubernetes on your own set of machines. So that is the benefit, the biggest benefit of Kubernetes. Other than that is things like auto healing. You just have to run a few commands and tell KR 5 pods need to run. And if one goes down, it automatically figures out when to start another one. AWS auto scaling group isn't as flexible, right? The thing that we discussed is you can start 3 machines. You can start a node app over here. You can start a node app over here, whatever. It did not give you things like, if this machine is getting heavily loaded, so I'll start this container on another place. The thing about Kubernetes is you have a swarm of compute. I repeat, you have a lot of compute. What does compute mean? CPU, RAM at your disposal in a bunch of small machines, a bunch of worker machines. And then you can tell Kubernetes, I need to run 10 things. Kubernetes will figure out that these 10 servers are the best place for me to put these mini containers. It's a container orchestration tool. AWS auto scaling groups, the thing that we discussed, they're not really container orchestration tools. There are other container orchestration tools like ECS. ECS was sort of the answer that Amazon had to Kubernetes, but if you use ECS, you are restricted to Amazon only. If you use Kubernetes, you can use any provider. You can move from one provider to another, or have multiple providers. Yet run a single command. You can have multiple providers otherwise as well. You can be like, Dharkira, this is my load balancer in AWS, which points to a bunch of machines in DigitalOcean and a bunch of machines in AWS. You can do, ad hoc multi-cloud setups like this as well. But, here your load balancer at the very least is in AWS, right? That problem will remain in Kubernetes as well. But it isn't very easy for you to run a single command. kubectl apply new _backend _image, let's say, and it gets deployed automatically here and here. You will have to figure out some, DigitalOcean deploy image 1 and then run AWS deploy image 1, so on and so forth. So, that's why you might want to use Kubernetes over, other container orchestration tools or non-container orchestration tools, simple auto scaling groups. If nodes are, okay, so that understood almost every concept individually, but I'm not able to connect the dots. Maybe explain this in the context of some real example I have. Okay, tomorrow we'll do that. Then example, let's say I've triggered a deployment on a huge system. How would the step-by-step work, and what are the pros and cons of every step? Yeah, if you want to know the real step-by-step, there is a slide here after deployment that covers this. Let's see. After we do deployment and replica sets, there is this step-by-step breakdown of what happens when you create a deployment. A deployment is very similar to, just like pod is a service, deployment is also something that you can create. And once you create a deployment, it iteratively creates pods. And once we reach here, there's a step-by-step breakdown of everything that happens, including the internal architecture of the kubelet does something, the scheduler does something, or the database may you store something. But let me think of a real world example before tomorrow. Okay. Why I get this message when I create the manifest.yaml? Also, it was not ready. Why? One or more containers have resource limits. This could starve the other processes. Most probably you're running it on a very small machine or something. Maybe try just one worker, or maybe just try a single node setup. Just try a single, because there are some machine requirements when you're running kind. So most probably you don't have those requirements. Let's see. Require, at least that is the case for Minikube. That would be my guess basically. Try to create a single container. Let me also Google your error for you really quickly. One resource limits. Copy. If we move completely to 100 functionality, right? If you want, it will need to have sign up functionality. That is correct. Notion doc. Link to slides is on projects.netexapps.com. Recap the node cluster process. Oh, create the node cluster process. Okay. Number one, create a cluster.yaml file that looks like this. You can find this in the slides if you go to projects.netexapps.com. Sort this by newest first. Go to the slides. Go to slide number, creating a Kubernetes cluster. Install kind, and then copy over this config. This config is basically going to tell kind, okay, you need to start 3 containers, a control plane, a worker, and a worker. Basically a 3 node setup. And then you run this command. Kind create cluster. Give it a link to your clusters.yaml file. Give it a name and you're good to go. Can we port forward pod to my local host to discover it? You can do that, but you won't do that in production. You can do that now. You can do port forwarding just to test this out and see if your Nginx container is running. But how do you do it in production? You create services, load balancers, ingresses, bounty. I have added the official links. हाँ पे ले जाना यार, कोई issue नहीं है. Let's see. Nice. That's cool. Oh yeah, there you go. Yeah, it should be fine. All right. Setup with case. What do you mean case? Can we change the image registry? You can change the image registry. I mean, if you want just another Docker image registry, then that should be fairly straightforward. You can, cat manifest.yaml. You can change this from Nginx to be, the complete URL from your registry, or maybe there's a way to pass in the registry URL. Most probably, if you change image to be the complete registry URL, it should work fine. Let me see. Let me try that out. Manifest.yaml hub.docker.com. Let's see if this works. If it doesn't, there's a way to change the registry to be whatever you want. Let's see. Apply kubectl get pods. Invalid image name. Yes, this is not the right way, but Kubernetes manifest registry ECR. Yeah, basically you'll find it here somewhere. Image AWS. Yeah, you can give the URL like this. Image dot. Yeah, basically replace this with your URL, and you probably have to pass in some credentials as well if you want to pull it from a private registry. Let's see. Yeah, feel free to drop off, guys. Like this, done for the class. Just answering questions, looking at chat, nothing new. Like nothing else. Not going to teach anything else. Can we change the image registry? Okay, answer that. Why I get this message when okay, answer that. Does Kubernetes help in zero downtime deployments? Yes. Specifically the thing that we'll be learning tomorrow, deployments. when you create a deployment here na, when you create a deployment, this thing specifically makes sure that, you know, if you're trying to upgrade from one version to another, it will first start a few pods for the new containers, for the new image. Only if they are working will it start stop the old ones. If you go through the slides, you'll find something like exactly what you want. Okay, if you want to ever move over from one image tag to another image tag, if you have an upgrade ever in your system, it will first start. If you're using deployment, if you use pods, then you'll probably, you know, stop the first pod, start the second pod. That will be a problem. But if you use deployments, then it will first start your pods for you. Only if they are healthy will it stop the old pods. All right, let's do one more round. There's a Notion doc as well. Who will decide how many containers will run inside one pod? The developer will. When I am writing this manifest file, I am telling it, yeah, I just want one container. If I update this manifest file to add, you know, name, Postgres, image, Postgres, Nginx, and you know, whatever ports, container port 5432. Then I am telling it, here when you start the pod, you have two containers to start inside it. This is a manifest for a pod, and I'm telling it, okay, you need to start two containers, container number 1 and container number 2. It is the developer's job to tell it the number of containers that are inside a pod. What is the second question? Does whatever is running inside one pod differ by port? Does whatever is running inside one pod differ by port? Is your question, can you run different containers on different ports on the same pod? Then the answer is yes. If your question is something else, please elaborate a little bit more. I'll refresh. Do containers within a pod share the same IP address? Yes. If I have multiple pods running, Docker, kubectl get pods dash -o-wide. If I have multiple containers running on this Nginx pod, then, you know, both of them will be referenced by the same IP. Of course, the ports are different, so they'll be referenced by different ports, but the IP will be the same. How can we move from one cloud provider to another? In a future session, could you show an example as well? Sure. We can do this as, you know, an assignment, but basically, the reason it's so cloud agnostic is that, you know, what did I have to do? Did I have to SSH into any machine? No. Did I have to run node index.js anywhere? No. I just had to run kubectl apply -f and then, you know, the name of the manifest file. I just had to run this specific command. Now, if I change the cluster that I'm connected to, I run this command, my application is deployed. That is the benefit. You know, that is why it is so easily cloud agnostic. Okay, you know, you just create every cloud lets you create a Kubernetes cluster. GCP lets you create Kubernetes clusters using something called GKE. AWS lets you create Kubernetes clusters using something called EKS. DigitalOcean lets you create it. Every cloud provider sort of supports it. And so thankfully, you just have to go to their dashboard, create a Kubernetes cluster, put the credentials here in .kube/config, and then simply run one command that will deploy everything for you on their Kubernetes cluster. So like, that's why it's so easily, you know, movable. Of course, you have to change domain entries somewhere, DNS entries, but other than that, it's, you know, one click move from this thing to another cloud provider. How can we move from, okay, answer that. How many clusters can we create and run? Oh, as many as you want. Is it related to the environment we have in a company such as, oh yeah. So you will have multiple clusters. That's a good question. If you have a company, then, you know, you'll have a staging cluster, which probably just has, you know, one master node and then maybe 3 worker nodes just for testing. And then you might have a testing cluster. And then finally, your prod cluster might be very big, might have, you know, 5 master nodes and thousands of worker nodes based on, how big your company is. And yeah, whenever someone pushes something to GitHub on, the staging branch, then you would update your staging cluster. Whenever this goes into the test branch, then you would update the test cluster. Whenever this gets merged finally to the production or the master branch is when you will update everything in the production cluster. All right, time to open chat one more time. Any more questions, guys? Is it actually important for people in college? Well, it depends. Are you looking for an internship? So depends. If you want to target cloud companies, then yes. For example, Civo hires pretty aggressively. A few people, third year college I've met, this time I was in Bangalore, who got into Civo. Civo their primary office is offering is Kubernetes, I think. So, there are DevOps companies, if you're targeting them for interns or otherwise, good skill to have. Most companies don't use Kubernetes, unfortunately. This is, very twisted, very big companies will use it. Startups will avoid it for good reasons. You should avoid using Kubernetes, just adds extra complexity to your system. So you don't really need it unless you are thinking of going into like a DevOps company. VMware, Civo, what is another good company in this niche? Nutanix. What is that? Forgot the name. There's another one in India. Bunch of these cloud companies that provide Kubernetes clusters to companies. If you're thinking of going into them, then you bare minimum you need to know is going to be this. If you're want to go into full stack companies, most full stack companies don't use Kubernetes to deploy, so you should be fine. What is load balancer, and why do we use AWS load balancer? Load balancer, as the name suggests, you should go to the auto scaling ASG class, auto scaling groups class, where we discuss this a little bit more. But a load balancer basically is, in the end, if you go to Swiggy, there are a million people who are hitting the Swiggy servers. A single backend server isn't enough for Swiggy. Swiggy needs a bunch of backend servers. But at the same time, in their browser or like whatever, in their mobile app, they don't want to have, multiple URLs. Okay, you go to backend1.swiggy.com. They just have api.swiggy.com. The mobile app simply hits api.swiggy.com, which usually is a load balancer, which will route the request to, one of these servers based on some round robin fashion, which server has the least load right now, some algorithm that the load balancer of that cloud provider might have written. AWS lets you create load balancers. GCP lets you do it as well. This is how/why you would use load balancers, irrespective of if you're using Kubernetes or not. When you are using Kubernetes, then you have a cluster where you have multiple, worker nodes or otherwise. And Kubernetes also lets you do some cloud specific thing. As I said, it's very easy for you to move from one cloud to another, but there are some things that are cloud specific. Whenever you start a Kubernetes cluster on GCP, AWS, doesn't matter. All the nodes are, running very similar code. All of the nodes are running Kubernetes with, some of them being run as a worker, some of them being run as the master. But the load balancer is something that exists outside the cluster. You can use cloud specific load balancers on top of your Kubernetes cluster. We'll discuss this when we reach, ingress and services specifically. There's a service type called load balancer that becomes cloud specific. And if you run it on DigitalOcean, you'll get a DigitalOcean load balancer. If you run it on AWS, you'll get a AWS load balancer. I thought we'll be having a session on advanced Docker and Docker Swarm and Kubernetes flavors. Can we expect Docker Swarm? We can. Docker Swarm is actually a good foundation to understand before Kubernetes. Advanced Docker, let's see if there is something we've missed in 0 to 1. Let me go through the 0 to 1. I'm pretty sure we've covered everything in 0 to 1, but if not, then we can have, I think we've covered. We can do Docker Swarm, but I don't think there's any need for a Docker advanced class. Docker Swarm, we probably should understand. Probably should have done that before Kubernetes. Would have been a good foundation for Kubernetes. How Kubernetes is charging money to use these services? It isn't. Kubernetes is an open source project. It doesn't charge any money. it was meant. How does Express charge money? It doesn't, right? The developer doesn't make any money. They've created an HTTP server for people to use. Similarly, Kubernetes is owned by some foundation that doesn't really care about money. Google also has a bunch. How does Flutter make money? It doesn't. It's just how does React Native make money? It doesn't. So, a software like that people can use. You can build business on top of it. Whoever is part of the core Kubernetes team can do consulting, help people deploy Kubernetes clusters, yada yada yada. But there's no, in the algorithm itself / the Kubernetes code itself, there's no, or you can extract some money out for the developers who've written the code. I'm preparing for CK, Certified Kubernetes Analyst, and learning these technologies like Jenkins. That's the name of the certification that you can do if you want. And learning Jenkins, Terraform, etc. Do they hire freshers for DevOps role? Bhaiya, do I need more Kubernetes commands in the Notion doc I've created? Explain. Let's see. Let's look at your Notion doc. If you are preparing for CK, companies do hire at least interns. Sivo had a lot of decent bunch of interns this time. So that's one company I know in cloud that hires. I'm sure there are a bunch of similar startups that I'm not sure. I mean, I can't really haven't ever applied as an intern for a DevOps company, but I know a few people who recently have. So yeah, it's a good certification to have generally though. Certified. The thing about Kubernetes is not a lot of people are doing it right now. Unlike full stack, everyone's doing it. So there's less competition. Are there enough job opportunities? I don't know. I don't think I have a good answer for that. All right. Will this be enough to follow along you replit clone video? Not this, not today. Ingresses after we do, then yeah, should be straightforward after that. Also, my AWS gets suspended. Do I need for tomorrow class? No, you don't need the AWS account. Create a Vultr account. Yeah, you might need an AWS account actually. When we reach load balancers, you might need an AWS account. We probably won't be reaching it tomorrow. But yeah, have one before next week basically. How can we run their applications in EC2 using Docker? What do you mean their applications? Like, where is the production database stored in this case? Won't the database go away if the machine crashes? Is there any lecture I could look at to clear the concept? It's a great question. Question is, would you run database in this cluster? I don't know if that is the question, but that is a good question. Maybe the question was something else. Either way, yes, the database, if it crashes, your data does go away. So, you have high level of replication when it comes to creating a database. Whenever you're creating a database, you don't have a single EC2 machine you're running it. You have a bunch of machines that are replicating data. So if you do a lot of times across various regions, so, if the data center in Mumbai goes down, your data is still replicated over here. Thankfully, if you use AWS to create what's it called, RDS, like AWS RDS to create a database, it just gives you an option. How many masters do you want? How many slaves do you want? So you can just increase the number of machines that you want for resiliency. And specifically in context of Kubernetes, yeah, you just avoid as much as possible to, start a database or a Postgres container over here for multiple reasons. One is, yeah, we can get into this later on as well, but biggest thing is pods are ephemeral, which basically means, if a pod starts, there's a good chance it dies, data will die with it. So, you have to create something called as a persistent volume. If you want to really host your own database in Kubernetes, you have to use something called persistent volumes, which, as the name suggests, let you persist data, even if a container, let's say, dies. It's non-ephemeral basically. But you avoid this totally. You usually avoid this totally as well. You use a service like RDS, Cockroach, DB, Neon, whatever, that handle a lot of this for you. They've handled all the resiliency. In case one of the data center goes down, they have your data replicated in another place. There is no video that covers this, at least that we have. We should probably have a video on master slave architecture and how can you have multiple servers, multiple DB instances. Akash, just make a note of this. Let's put this in the stack of offline videos. But yeah, to answer your questions, you have a lot of replication. But again, in the worst case, if every data center today goes down, then sure, your data is lost. Nothing you can about it. You back up data from time to time. What you do is, if this is your database that's running on, let's say, EC2, even if it's running on a single machine, once every 20 minutes, you back it up in some local storage of yours. You have a NAS at your house or, S3 somewhere. Every 20 minutes, every hour, you can take a whole snapshot of a database and post it somewhere, so that even if this goes down, you can at least recover it from some timestamp. All right. Difference between metadata name Nginx versus containers name. Oh, great question. Question is difference between metadata name Nginx and container name Nginx. This name is the name that you see when you do kubectl get pods. This name right here, versus the other name is just an identifier for the container. Okay, this Nginx container is called whatever you can call it. Better name here might be Nginx dash container, and here might be Nginx dash pod dash container. So these are the names of your containers that are running. This top level name is the name of your pod that is running. If I do a kubectl apply manifest, I've messed up this manifest. Let me delete these. Apply. Then if I do a get pod, my second pod is named Nginx pod, but the container that is running inside is called whatever Nginx container or whatever you've put inside here, this name right here. So this is the name of the pod. This is the name of individual containers. If you have 20 containers, you would give each one of them a name. All right. So images have volumes. Where is the volume stored? You mean containers? You mean pods? Pods have volumes? Could you repeat the question? Basically, yes. Whatever pods you start over here, they do have access to some volume / file systems. You can, where is the container? If this is your, cluster, whatever pods you start, I'm assuming you meant pods, have access to the file system over here, but they're ephemeral, which means if the pod dies, all that data is gone. It's very similar to Docker, right? If you do a Docker run, whatever, I've done this, Docker run something, and then if I try to go into this container, if I go into this container and then do mkdir test, I create a test repository, go to the test repository, create a test file, probably cannot do that, create another directory over here and exit. If the container dies, file system dies with it. Whenever I recreate the container, the new container won't have the test folder that I had created. So there are ephemeral volumes / file systems that you have access to, but they die when the pod dies. That is exactly where persistent volumes come into the picture. Here you mount a persistent volume to a pod so that whenever a pod starts, the data that's being stored here is being persisted somewhere else. Even if this pod dies, this data doesn't die with it. If that was your question. So we can have, okay, answer that. I'm preparing for CKA as well. Okay, answer that. Kubectl is running as a wrapper class of Docker. No. Docker, when you run whatever Docker run, it sends a command to the Docker daemon, to a Docker HTTP server. Not an HTTP server, like whatever Docker has a certain socket where it's listening. You send a request there. And when you run kubectl get pods, it sends a request to, for example, this specific URL 127.0.0.1/583. So they're different. This CLI Docker command line interface is to talk to the Docker daemon that's running. This CLI, the kubectl command line interface, is to talk to the Kubernetes API server. All right. More questions. It's like, might take a long time, Kubernetes, from what I can understand right now. All right. Let's do it. Great question. Suppose we want to run 10 pods. How do we configure their names? Do we need 10 YAML files for that? Good question. So you don't need 10 YAML files. You can, number one, the easiest thing you can do is this. Okay, in the same, let me open this in Visual Studio Code. File. The easiest thing that you can do is have, multiple pod specifications in the same YAML file. Okay, I'm creating a pod over here whose name is nginx pod, and then the other one whose name is nginx pod 2. And you can have multiple of these in the same file. And then whenever you apply it, kubectl apply manifest.yaml. It says the first pod is unchanged and created the second pod. So you can either have multiple, definitions in the same file. I can add a third one, fourth one, so on and so forth. Or what you can do is you can use a deployment, the thing that we'll be doing tomorrow. You can create a deployment and you can mention, okay, I need 100 replicas over there. Basically, when you create a deployment, you can give it something like this. Okay, I want 100 replicas. It will under the hood create 100 pods and name them, with some random name. We'll see this tomorrow. So yeah, you use deployments when you want to do something like what you want. You don't have a single file in which you describe, 100 pods. How do people relate hardware? Is there any limitations, like one pod can only run on one core or something like that? You can put limitations. You can say okay, one pod will require at least 0.5 or 1 vCPU, let's say, or 0.5 GB of RAM, things like these. That becomes useful when you want to auto scale. If you want, basically this will come in handy if you're ever doing the Replit clone on YouTube. Okay, on Replit, whenever a user comes to your website, you want to give them a container that has at least 0.5 GB RAM and 1 CPU of core. So if your Kubernetes cluster only has 10 machines, let's say 1, 2, 3, or 3 machines, let's say, and each one of them is, let's say, 32 GB of RAM, then you can at max run 32 into 3 into 2, these many containers, because you put a minimum requirement. Okay, every user of mine needs at least 0.5 GB, which means amongst these 32, I only have this much GB of RAM available. I can only run whatever the sum of these three is into 2 number of containers at max. Uske baad, if I have more users, I will have to auto scale and increase the number of machines that come up. Long story short is yes, you can put limits like the minimum amount of CPU that this pod should have, or the max amount of CPU that this specific pod can take. How pods relate? Okay, answer that. As Node.js is single thread, can't utilize all cores. I may have 4 pods running on the Node.js process utilizing the available cores without the cluster module and will be taken care of by the Yes, you can totally do that. You can have without having the cluster module. If your Kubernetes cluster has a 10 core machine, you can run 10 pods over here. You can also run 20 pods over here, because not every Node.js process will have the thread active all the time. A lot of times the thread is idle as well. So you can run 10 Node.js processes here, and you can sort of, yes, you do what the cluster module does without using the cluster module. You can have 10 containers over here, and whenever the request comes, it will go to one of these 10 containers. You were able to use all the power of your machine without having, even when you're using a language like Node.js, which is single threaded. We also had topics that robust design. Okay. How pods, okay, answer that. I'm new to Kubernetes. Will you show shifting of architecture from one host to another without loss of data? Can you check the deploying architecture explained part? Sounds for referral. Referral, I would strongly urge that you contribute somewhere, like in one of our projects. And what is the question? Check the architecture explanation. Hi, Keith, I'm new to Kubernetes. The loss of data. So loss of data specifically will happen if you are moving a database. If you are number one, if you ever store your data in the Kubernetes cluster, which, as I said, most companies don't. Probably 95% of the companies never use Kubernetes for their database. They will use it for their API servers. They might use it for their front ends. They will never use it for your database. So as long as you don't have your database in Kubernetes, it doesn't matter. Your data is somewhere else only, either in RDS, or you have your own Neon, or you have your own, cluster of machines where your database exists. Your API is the only thing that's on Kubernetes. So even if you move from one place to another, your data is still intact, and you have zero data loss basically. There's another good question here. Okay, let's see. Container orchestration. What are containers? An isolated environment that contain everything an application needs to run. That is great. They are portable, efficient, and easy to use. Example, Docker lets you create containers. That is correct. Container orchestration. Managing the lifecycle of containers, especially in large dynamic environments. It involves deploying, scaling, and managing containers. That is right. Why do we need container orchestration? Starting up a single container requires a lot of manual work. Imagine managing a cluster of VMs and containing multiple containers. Starting container actually does not require a lot of start manual work. Yes, it does require a lot of manual work. That is correct. If we want to manage these clusters for us, like simply provide a script that someone else and then take care of. Exactly correct. If we want to move our cluster containers from one host to another, we need to make sure the containers are running and the data is not lost. It's very hard to move things from one machine to another. And stop a container here, start a container here, make sure the total count of container is always 2, things like these. Along with the above points, what if we can monitor the health of our containers, and if they're ever unhealthy, we can restart them automatically? Exactly. That's where container orchestration comes into the picture. That is right. Before Kubernetes, this is how you would deploy. That is correct. Deploying with Kubernetes. In Kubernetes, if we want to start a container, we can start a pod. A single pod can contain one or multiple containers. That is correct. A node is simply an EC2 machine where we can run our containers. In Kubernetes, we divide it into 2 categories, master and slave. That is correct. Master and worker. Master nodes are responsible for managing the pods, and it's the master node's responsibility to deploy a bunch of containers as per the requirement and manage them. That is correct. It's its responsibility to put some things in the database, and it is the responsibility of a kubelet to pull it. So master node doesn't do everything. There is something running on the worker node that also takes part in understanding. Yes, I need to start a container. So not 100% true, but like pretty close. Master node does most of the work. Worker nodes are the ones that actually run the containers. Kubernetes cluster is a collection of master nodes and worker nodes. Master node and worker node internals. That is correct. Happy slides, Mary? It's good. Very good. I like it. This is how you create a cluster. Docker ps to see the files. Delete the cluster. Check the number of nodes running. That is correct. Check the cluster info. That is correct. Find the credentials over here. Install kubectl. Get the nodes with a lot of verbosity to see the final endpoint it is running. Get the pods. This is how you run Nginx using Docker. This is how you run Nginx using kubectl or like in a Kubernetes cluster. Delete the pod, create a manifest. Bro, this is like easier to understand GitHub versus compared to our slides. For some reason, this is like much more smoother than the slides that we write, and go to the next one. Apply, get pods, delete, and then checkpoint. Very cool. You should do this for all. Oh, you do this for all. Never mind. Let's see. Oh, fucking A. Very cool. Very, very cool. Every week. Not every week, but like pretty close. All right. Let's go back to chat. Pretty cool, man. Yeah. Most of this thing is right. Perfectly summarized. All right. Let's suppose you want. Okay, answer that. All right, guys. Last call for questions. Anything else before we call it for today? Tomorrow's class will also be pretty simple. I think. Very hard. It'll be very long. Kubernetes is what I think. All right. I have 20 bare metal servers with 4 GPU cards and have 150 users for AI ML computation tasks. Should I use Slurm or Kubernetes? So everyone gets a fair share of resources. Now Slurm is something I've learned for the first time. Slurm. Workload manager. Yeah, no idea what this is, man. So would basically not answer this considering I don't know what this is. Resource management you can do fairly well with Kubernetes. Whenever you're creating a pod, put some resource limits to make sure people are not. I don't know if you can do that for GPUs. Probably can, but I don't know if there's an easy way to do it for GPUs. Restrict access to GPUs. Maybe there is. I don't know, but that's the only tricky bit in Kubernetes. Basically, Kubernetes gives you everything you need. So I don't know if you need Slurm, but if Slurm or whatever that tool is good for resource management per user, then probably a good way to go. So basically, I did not answer this question at all. You will still have to decide yourself. But Kubernetes will give you all the constructs to do it, at least on the CPU level. Pretty sure on the GPU level as well. Let's see. Kubernetes Resource limits on GPU. You can specify GPU limits without specifying requests because Kubernetes will use a limit. So yeah, pretty sure you can do it. All right. If you want to move completely to, we have to add sign up functionality. That is correct. We probably have to add like a email password thingy, and that means we'll have to add like some email provider first. Yeah, I'll have to get like some SMTP credentials, and then we can go from there. Or we can do login with Google, but there's a problem with login with Google. A lot of times when people buy, they don't have this. You basically need email password. If you need email password, we need an email provider that we can send emails from. So yeah, first need to figure that out because that's always tricky to get SMTP credentials. You get banned from time to time. You shouldn't depend completely on it. So yeah, we should have a login with Google, login with whatever, GitHub, and then an email password login as well. Recently, I came across a few companies that cannot use cloud providers due to security reasons. Instead, they have their own data center. Sounds good. This means they're managing the deployments in Kubernetes. Not necessarily. I mean, just because you have your own cloud your own data center doesn't mean necessarily you're using Kubernetes. Most companies do. If you move to your own set of data, your own set of servers in a data center, most companies, actually, this is just a rough estimate. If I would do it, I would probably use Kubernetes. Someone mentioned something about Dukan moving away from Kubernetes. Let's see. Since Dukan moved off cloud, where is it running its database? Maybe their server that's in their office, or maybe their database is still on cloud. I would assume the database is still on cloud. Maybe it's not. I mean, those guys are highly risk. They have a lot of risk aversion, so maybe they just hosted the database in-house as well. I would assume though, a lot of their API servers are in-house, but the database is still on cloud. Could be wrong. So, in that case, probably in a server in their office is where they have a lot of their data, like that's where they host the database. Maybe. I don't know if I would do that. Maybe they do though. They do a lot of counterintuitive things. GitHub promotes and resembles open source, but ironically the code isn't running. GitHub is open sourced. What are your thoughts on this? Yeah, it's fine. GitLab is open source. It's fine. You would just use GitLab. Many big companies like OpenAI, that tells you, open source necessarily doesn't always win. Even though in such a controversial open source world, the biggest company is closed source. What does that tell you? Open source isn't a moat really. Just because GitLab is open source doesn't mean they won. Big companies like OpenAI, Netflix, Airbnb are using Datadog for log monitoring. Why can't they self-host? Because Datadog becomes expensive at scale. They probably get a lot of discounts, and they don't want to have that challenge in-house. Why don't companies move to data centers when cloud providers are so expensive? Because they just get discounts and they're like, TKR, AWS does provide me a lot of patching, gives me very nice APIs, so I'll just use them. It's fine. So a lot of times companies don't care about the money they're spending, and also can get a lot of discounts at scale. Okay, answer that. Currently intern at something as a Selenium automation engineer. My internship ends in July. I was supposed to get a PPO, but I was revoked due to budget issues. Okay. I've gotten 2 clients with freelance opportunities. Should I look forward to freelancing for the next few months or year? Would it be considered as an experience? Yeah, you can always put that as an experience. Once I start applying it, yeah, it should be fine. Try to go for longer term gigs. That's the only thing. At least 6 months gigs basically. But yeah, other than that should be fine. You can always put it up on your resume if that's what you're asking. Alrighty guys, we'll call it here. Thank you everyone for joining. Tomorrow, let's do a quick recap, some real world examples, and then let's dive into pods, deployments, services. Let's see how far we can go. Then we'll follow up with some offline videos. I will see you guys next week. Bye. No tentative date for Web3 Code, unfortunately, but meetup date is finalized 6th of July. Bye guys. Good night.